Greetings. In today's lesson, we're going to talk about expressions of concentration in pharmaceutical calculations. Specifically, we'll be covering percent strength, ratio strength, and parts per million. It's important to really have a mastery of these concepts because pharmaceutical calculations problems will not always cleanly give you the weight or the volume of a drug in things like grams and mils. Instead, the problem may express it as one of these expressions of concentration, and you have to be able to convert. So let's go ahead and start with percentage strength. So percentage strengths can come in one of three ways. It can be a percentage strength expressed as weight by weight, a percentage strength expressed as weight by volume, or a percentage strength as volume by volume. No matter what's going on, though, there's some things that are consistent. You're going to notice that the denominator is always 100. So when a percentage strength is given, the number itself becomes the numerator, as you can see here, 12, 12, 0.3, 0.3, 42, 42. And 100 will always be the denominator. The other consistency of percentage strength is the units are always either going to be grams if you're dealing with weight, or mils if you're dealing with volume. So with these simple rules, we can go ahead and solve some problems. So let's look at this first one here. It's saying that we have an intravenous injection that is a 20% weight by volume of mannitol, and it wants to know how many mils of the injection should be given to give a patient 100 grams. Well, let's start with what we know. We want to give the patient 100 grams of the drug. Now, how do we convert? Well, weight over volume, and we're going to reverse it because in this case, 20% means 20 grams over 100 milliliters. But we've got to flip it upside down in order for our grams to cancel out. So essentially, if we want 100 grams, and the concentration it comes as is 100 milliliters per 20 grams, we would then solve for 500 milliliters. But again, this 20%, what it means is 20 grams over 100 milliliters. The reason it's 100 on the bottom is because in percentage strength, the denominator is always 100. The 20 comes from the 20%. And again, the reason for the units is units are always grams or always mils. Let's go ahead and look at another percent strength example. In this case, we're asked to prepare 250 milliliters of a lotion using 4 milliliters of phenol. And so what we want to know is what is the percent strength of phenol in the lotion? Well, what we know for sure is that there's going to end up being 4 milliliters of phenol and 250 milliliters of the lotion. So this is simply a ratio where we have to convert it to find the percentage strength. It's volume by volume. Remember, volumes for percentage strength are always milliliters. We've already got that going on. So all we have to do is solve for percentage strength. So remember, in a percentage strength problem, the bottom denominator is always 100 using the unit that's appropriate, and then the x percentage strength is the numerator. So we solve for x. And as we do this then, we get that x is 1.6%, meaning that this is a 1.6% volume by volume solution of the final product. So let's move on and talk a little bit about ratio strength. Ratio strength, unlike percentage strength, is about parts. So in this case, it's always going to mean 1 part to x parts. And so the consistent here is that the numerator is always going to be 1. The units are easy though. It's the same as before. If we're talking about a weight, it's going to be grams. If we're talking about a volume, it's going to be milliliters. And so again, your ratio strength will always be shown like this, but it turns into your numerator over denominator. Because this is 1 to 400 means 1 part to 400 parts. Let's say we were told that a ratio strength of a solid and liquid was 1 to 400. That would mean then 1 gram over 400 milliliters. Okay, so let's go ahead and look at a problem. This one's asking us to solve for milligrams of gentian violet in order to prepare a compounded solution. And what it's telling us is that we're going to end up with 500 milliliters of the solution, and that we have a 1 to 10,000 ratio. So basically, how much do we need to get that? Well, okay, we want 500 mils of solution. We know that we want its ratio strength to be 1 to 10,000. Because it's a solution, And because we're asking for milligrams of genitin, we can say that this is, or gentian violet rather, we can say that this is a gram over mil. So that means we're preparing 1 gram per 10,000 milliliters. And so the amount of drug that we would have to add is going to be 0.05 grams. And again, I've solved for grams because of this. However, it asked for milligrams, so to get my final answer, I have to multiply that 0.05 by 1,000 to get 50 milligrams as my correct answer. You may also be asked to switch back and forth between percentage strengths and ratio strength. This is one that's saying express this ratio strength of 1 to 250 as a percentage strength. Well, in this case, the units don't matter. It's not telling us it's a weight by weight. It's not telling it's a weight by volume. It doesn't really matter. We can still convert, and it's really easy. What does 1 to 250 mean? It means 1 over 250, no matter the units. What's a percentage strength? Well, percentage strength is always X over 100, no matter the units, because in this case, the units would cancel themselves out. If it was volume over volume, it would be mils over mils over mils here, or it could be grams over mils. It doesn't matter. So this is a really easy problem, and when you solve for X, it's a 0.4% strength. So hopefully that helps clarify the difference between percent strength and ratio strength. Finally, we're going to talk about parts per million. In parts per million, if you're told that something is X parts per million, it always means X parts in a million parts. You may also see a parts per billion. It's going to be the same thing. It just means your denominator is going to be 1 billion instead of 1 million. It's the same default units as ratio strength, grams for solids and mils for liquids. So again, let's go ahead and look at an example problem. This is saying that we have a commercially available insulin, and the insulin is 2 parts per million. So we want to know how many micrograms would be contained in a 10 milliliter vial. Okay, so I have a 10 milliliter vial. What is my concentration? It's 2 parts per million. So what does that mean? It means 2 grams, because remember, it's always going to be grams or mils. So 2 parts per million means 2 grams over 1 million mils. But we're going to eventually need to solve for micrograms. So we're going to have to multiply by 1,000 twice, because we have 1,000 milligrams in 1 gram. And we have, sorry, I'm running out of a space, we have 1,000 micrograms in a milligram. So when you finally solve for this, your final answer, and I'll put it in green, is going to be 20 micrograms. All right, so with that in mind, here's our summary. Percentage strength. Percentage strength is always going to have a denominator of 100, and the numerator will be the percentage strength expression. So if it says 4%, the numerator is 4. If it says 3%, the numerator is 3. And the units are always milliliters or grams. Ratio strength, the numerator is always 1. It's the denominator that changes, but again, the units are always milliliters or grams. And then in parts per million and parts per billion, the denominator is either 1 million or 1 billion, and the numerator is whatever it tells you. So if it's 2 parts per million, it's 2 over a million. If it's 5 parts per million, it's 5 over a million. And again, the same units. Mils for liquids, grams for solids. Thanks for listening, and go practice some problems.